This slide and the next few slides discuss keyed contexts. Apply a keyed context to statements that should be repeated by every unique key value. The syntax is: the create context keywords, then the partition keyword and the optional by keyword, then an event property name, then, optionally, the and keyword and additional event property names, then the from keyword and an event type name, then, optionally, the terminated keyword and the by keyword, then the terminating condition. The partition keyword provides event property names and event types that provide the unique key values. The context has one partition for every unique key value. For events of the listed event types, the runtime determines the key value and routes the event to the partition for that key value. The optional terminated keyword and terminating condition can terminate partitions. Without the terminated keyword, the partitions do not terminate. The compiler validates that a statement that applies the context must have at least one event type that is the same event type as listed in the partition clause. The compiler validates that, in the partition clause, when there are multiple event type names, the number and value type of the event properties of the different event types are the same. The expression context.key returns the key value. For multiple keys, the names are context.key1 to context.key n, where n is the number of keys. To illustrate, the first statement defines a context that partitions by user. At public, create context partitioned by user, partitioned by user ID. From page hit. The next statement outputs the count per user. Context partitioned by user. Select user ID, comma, count star. From page hit. When a page hit event comes in, the context checks whether a partition for the user is already allocated, and if not, it allocates a partition. The runtime routes each page hit event to the partition for that user ID. Therefore, it is not necessary to specify a filter condition, and from page hit is sufficient. Also, it is not necessary to specify group by user ID, since each partition is specific to a user ID, and each partition stores the count. The from clause can list common filter conditions. This example also demonstrates the termination condition. The first statement defines a context that partitions by user, and that only processes user ID U1 and U2. The context discards each user's partition after 10 minutes. At public, create context partitioned by user, partitioned by user ID. From page hit. Parenthesis. User ID in. Parenthesis. Quotes U1. Comma. Quotes U2. Terminated after 10 minutes. The next statement outputs the count per user for users U1 and U2. The output is 10 minutes after the first page hit event for that user. Context partitioned by user. Select user ID, comma, count star. From page hit. Output last when terminated. The initiated keyword can be used to name those event types that allocate a new partition. For instance, the first statement defines a context that partitions by user. Only a login event allocates a new partition. A logout event terminates the partition. Create context user session. Partition by user ID from login, comma, user ID from page hit, comma, user ID from logout. Initiated by login. Terminated by logout. The second statement starts counting after a login event arrives and outputs the count for the user when a logout event arrives. Context user session. Select user ID, comma, count star. From page, hit. Output last when terminated. This slide provides explanations for the prior example. Upon deployment, the context waits for login events. When a login event arrives, it allocates a partition, unless there already is a partition for that user ID. When a page hit event arrives, the runtime routes the event to the partition responsible for that user ID. When a logout event arrives, the context terminates the partition. When a logout event arrives, the statement outputs the count. As compared to overlapping contexts, with the keyed context, each partition is dedicated to processing a specific user ID. As compared to overlapping contexts, the runtime routes events to the partition for that user ID. As compared to overlapping contexts, there is no need to specify a filter condition such as ... from page hit parenthesis user ID equals context.login.user ID. This slide and the next few slides are about hash contexts. Apply a hash context for statements that should be repeated an arbitrary number of times. The syntax is: the create context keywords, then the context name, then the coalesce keyword and the optional by keyword, then the hash function name and parameter expressions in parentheses, then the from keyword and an event type name, then, optionally, additional pairs of hash function and event type name, then the granularity keyword and a granularity number, then, optionally, the pre-allocate keyword. The coalesce keyword provides a hash function that takes parameter expressions as parameters. Typically, the parameters are one or more event property names. The hash context routes events to partitions based on the result of a hash function and modulo operation. A hash function maps data of arbitrary size to an integer value. An example is the Java hashcode method. The granularity keyword and number defines the number of partitions. The optional pre-allocate keyword allocates partitions in advance. The hash context can be used for performance tuning. Each partition has its own lock, therefore a hash context can provide arbitrary lock granularity. For a hash contexts, partitions never terminate unless part of a nested context. Nested contexts are discussed later. To demonstrate, the first statement defines a hash context with 16 partitions. The hash function consistent _hash _crc32 computes a hash code using the crc32 algorithm. The context computes the hash code for each user ID value. Create context partitioned by user hash. Coalesce by consistent hash crc32. Parenthesis. User ID. From page hit. Granularity 16. Pre-allocate. The second statement outputs a count per user. Context partitioned by user hash. Select user ID, comma, count star. From page hit. Group by user ID. Upon deployment, the context allocates 16 partitions, since the granularity is 16 and there is a pre-allocate keyword. When a page hit event comes in, the context determines the partition by computing. Partition number equals consistent hash crc32 parenthesis user ID modulo 16. This assigns each user to one of 16 partitions. Users are evenly spread across the 16 partitions.